In this video, we're going to take a look at some more complex proofs that involve the use of parallel lines. All right, so let's go ahead and get started. In example 1, we're given that lines L and M are parallel. So the very first thing I'm going to do is go to my picture and indicate my picture that they are indeed parallel. You may want to grab a highlighter and use the highlighter to indicate that they're parallel. And the goal that we're after, and the other piece of given information that we want to mark in the diagram is that angles 1 and 2 are congruent to each other. So I'm going to go ahead and mark angle 1 congruent to angle 2. Now you might be tempted to think that angle 1 and angle 2 have some special type of relationship, but if you look at angle 1, it lies on transversal A, while angle 2 lies on transversal B. And because they exist on different transversals, there's no special relationship between those two angles. Our goal or our mission is to prove that lines A and B are parallel to each other. You know, based on the work that we did yesterday, that in order to do this, we're going to have to find some congruent angle pairs or some supplementary angle pairs. Now, looking at the picture for the parallel lines L and M, if I consider that red transversal along transversal A, I know that angle 1 and angle 3 are corresponding to each other, and due to the fact that the lines are parallel, they must also be congruent. So now, if you looked at the way I've marked the diagram, not only are angles 1 and 3 congruent, but angles 3 and 2 are congruent as well. And angles 3 and 2 for lines A and B are corresponding angles. And we know that anytime we have corresponding angles that are congruent, the lines must be parallel. So that's what we're trying to show. In the picture, we've got a real good, clear vision of what's going on, but now we've got to go ahead and get that into writing. So I'm going to go ahead and start by saying that line L is parallel to line M. We know that's a true statement because it's given to us to be a true statement. And due to the fact that those two lines are parallel, we're able to say that angles 1 and angles 3 are congruent to each other. Because anytime we have lines that are parallel, so parallel lines, they have corresponding angles that are congruent. But we also know, because it's given to us, that angles 1 and 2 are congruent. And if angle 1 is congruent to 3, but it's also congruent to angle 2, we can put the green statement and the blue statement together. And we know now that angle 2 and 3 are congruent. And that's by the property of substitution, when equals are substituted for equals. Now the last thing, if we come back over to the picture, in the picture we've got angle 3 here and angle 2 here. Notice for the lines in the picture, I'm going to go ahead and make those green. For the green lines, with that blue transversal, angles 3 and 2 are corresponding angles. So we have ourselves a pair of corresponding angles that are congruent. That, in turn, tells us that the lines have to be parallel. So lastly, we can go ahead and conclude that the lines are parallel to each other. And the reason that we knew that is because congruent corresponding angles have lines that are parallel. We know it's okay to stop at this point because our goal or our mission was to show why the statement A is parallel to B is a true statement. We've explained that A is parallel to B is a true statement because of those congruent corresponding angles. So we know it's okay to stop. All right, and moving on to the next one, in example 2, we're given that angles 1 and 2 are congruent, so I'm going to go ahead and mark my picture with that. And we're given that angles 3 and 4 are congruent. Now be careful when you mark your diagram. You want to mark angles 3 and 4 congruent to each other, but not congruent necessarily to angles 1 and 2. Now because angles 1 and 2 are congruent, I know that lines L and N have to be parallel because anytime I've got alternate interior angles that are congruent, lines have to be parallel. Likewise, because angles 3 and 4 are congruent, I know that lines N and M must be parallel to each other. for the same reason. So I've got line L that's parallel to line N, so I'm going to go ahead and mark that in my picture. I've got line M that's also parallel to line M. I'm going to mark that in my picture. And notice, marked in my picture now, I have the very statement that I want to prove, and that is that line L is parallel to line M. So now I've got to get it out of the picture and into the proof. And for this proof, I'm going to write a 2-column proof with statements and reasons. But if you prefer to write a flow proof, you're always welcome to write a flow proof. I just want to switch things up for those kids that prefer the structure of a 2-column proof. All right, so I'm going to go ahead and start with these statements. Angle 1 is congruent to angle 2. I'm also going to put angle 3 congruent to angle 4 right in there. Anytime statements are true for the same reason, you can lump them or group them together within your proof. Because these statements are both true because they're given to be both true, it's okay to go ahead and put them in the same step. Now, because angle 1 is congruent to angle 2, that tells me that line L is parallel to line N. And likewise, because angle 3 is congruent to angle 4, I know also that line N is parallel to line M. And again, because these two statements are true for the same reason, using the fact that those alternate interior angles are congruent, I can go ahead and put them together in the same statement in my proof. So that's because anytime I have congruent alternate interior angles, they have lines that are parallel. And I'm going to go ahead and cite statement 1 because statement 1 is the statement where I was talking or speaking or referring to those congruent alternate interior angles. Now in the last step of my proof here, I'm all set to go ahead and conclude that line L is parallel to line M. And your gut probably wants you to use the same reason that we used in the first proof, substitution. However, what I want you to recall here is the property of substitution states that equals can be substituted for equals. And in this question, we're not dealing with equals, we're dealing with parallels. So you have to be very careful here only to use substitution when you're dealing with lines, or excuse me, when you're dealing with quantities that are either equal or congruent. So we have a very similar reason that we're going to use here. We're going to state that these two lines are parallel to each other because they're both parallel to the same line, i.e. line N. So anytime two lines that are parallel to the same line, just as these are both parallel to line N, must be parallel to each other. And I'm going to go ahead and cite statement 2, because statement 2 is where both of those lines were parallel to line N. All right, we've got one more to take a look at. I'm going to go ahead and scoot along to example 3. This one's kind of interesting because in this particular problem, we are giving not one pair of parallel lines, but two. So I'm going to go ahead and use my highlighters to highlight those. I'm going to highlight one pair yellow, the other pair green, and in addition, I'm also going to go ahead and mark them. So I'll do one set of arrows for the green parallel lines, 2 sets of arrows to indicate the yellow parallel lines. What I'm trying to prove, where we want to be at the end of the day here, is we want to go ahead and show that angle B is congruent to angle 7. So if I take a look at where these angles live in the picture, here's angle B, here's angle 7. It might be very, very tempting to say that they have some special type of relationship to each other. But for the green lines, if we look at the green parallel lines, they live on different transversals. If we look at the yellow parallel lines, again, they live on different transversals. And because no matter which pair of parallel lines we look at, they're living on different transversals, they don't have any or share any of those special angle relationships. So the little trick that we're going to use here is we're going to pick an angle that does have a special relationship with both of those angles. So looking at the picture, I can actually see 4 angles in the picture that I could potentially use that share a special relationship with both angle B and angle 7. So I like angle 5. He's alternate interior to angle B. He's corresponding to angle 7 for the green lines. I like angle 2. Angle D would be a good choice, as would be angle G. You could use any one of those pairs of angles in order to write the proof, but we're going to pick one and stick with it. So I'm going to go ahead and the angle that I'm going to pick to use my proof is angle 5. I know because the yellow lines are parallel that angle B must be congruent to angle 5, because anytime I have lines that are parallel, alternate interior angles have to be congruent to each other. Due to the fact that the green lines are parallel, I also know that angle 5 must be congruent to angle 7. Because again, once I have parallel lines, I know that all the corresponding angles have to be congruent. And if you look at the picture now, I've got angle B congruent to angle 7, so I'm exactly where I wanted to end up. And again, you could use a similar argument with any of the other highlighted angles in that picture. But angle 5 is the angle that I'm going to go with. All right, so I'm going to go ahead and start with my lines XY and ZW being parallel to each other. I know that's a true statement because it's given to me to be a true statement. And because those yellow lines are parallel, I know that angle B is congruent to angle 5. And that's because anytime I have parallel lines, I got to go back and get back where I'm working here. Anytime I have parallel lines, the alternate interior angles that are formed must be congruent. And likewise, due to the fact that lines RS and TQ are parallel, which is a true statement because it's given to me to be a true statement, because those two green lines in the picture are parallel, I also know that angle 5 is congruent to angle 7. The reason I know that is because anytime I have parallel lines, I know that the corresponding angles have to be congruent. And at this point, you may be feeling like you're stuck, but you're actually almost done because I have angle B congruent to angle 5 and angle 5 congruent to angle 7. So if we pull those two statements together with a little substitution, we realize that it is indeed true that angle B must be congruent to angle 7, because anytime we have equal quantities, we can always substitute one equal quantity for another. And that's all we're doing here. We're pulling out the angle 5, and we're replacing the angle 5 with its equivalent, which is angle B. All right, as always, thank you for the gift of your time. I do want you to take a few minutes and think about and reflect upon what are the key ideas and the important takeaways from this video, and then see what you can do with the proofs on the next page.